Hey guys, just as a reminder, on the test, I will have a problem like number 1, number 2. Well, I'll have a problem like number 1 where you have to graph it, or solve it by graphing, or solve it by substitution. And I'll have a problem like number 3 on the test. And the only way you can do that, number 3, is by substitution. Okay? Let me just say this, you guys. All these problems come out to be quadratics. Okay? You're going to end up solving quadratic equations in the end. That's why this lesson comes right after we learned how to solve quadratic equations. It's because to solve a system of equations where you have a quadratic and a linear, or a circle and a linear, they're always going to be coming out to be quadratics. And so that's the case. So we're going to take the test today. So we're going to go over this assignment. We're going to review for the test, and then we are going to take the test. So problem number 3. Problem number 3, we are given x squared plus y squared equals 25. And we're given that 4y equals 3x. Now, what? Yes. Yeah, it's right over there in the corner. Will you grab one? Anybody else not here last time? Wants to grab one? Okay. Because what kind of equation is this one right here? X squared plus y squared equals 25. It's a circle. Last time you were here, I showed you this. And I'm going to write it down really quickly. I'm going to go to another slide. I showed you that x minus h squared plus y minus k squared is equal to r squared. And this is the general form of an equation of a circle. How many of you have seen this before last week? How many of you have seen it? Where did you see it before? Which class? Last year? Because I was going to say, the way that this is presented, it appears to me that you guys should have been introduced to this last year. You guys remember graphing circles last year? No, never did. You just did the formula? No, well, actually, they touch on it so lightly that it looks like to me that they assume that you guys already know how to do circles. But so, well, let me give you another example. Let's say I was given this equation right here. X plus 4 squared plus y minus 2 squared equals, let's go 49. Okay? And so I want to know, where's the center of this circle? Well, yeah, I forgot up here, you guys. H comma k is the center. Did you remember that from last time? And r equals the radius. So in this problem right here, the general form. So going back down to this problem, what did you say, Cameron? Where's the center of the circle? 4 comma negative 2. We're going to switch those signs around. Okay, it's negative 4 comma 2. It's the center of the circle. If you look at up here in the original formula, it's x minus h. And down here also it says x plus 4. That's because this is x minus a negative 4. Does that make sense? So x minus a negative 4, so that's a negative 4. And this is y minus a positive 2, so that's a positive 2 right there. In other words, just take the opposite sign right here. If this is plus 4, you take a negative 4. If it's minus 2, you take a positive 2. And that's the center of your circle. Got it? What's the radius of this circle? 7. Because if you look up here in the formula, r squared is what's on the right side. Well, we only want r as the radius. So in other words, the square root of 49 is 7. Got it? Okay, so back to, and by the way, you guys, if I graph this circle, let me just show you. Negative 4, 1, 2, 3, 4, and then 1, 2 up. If I was to graph this circle, my center of my circle would be at negative 4 comma 2. And my radius would be 7. So what I would do is I'd go out 7 this direction. I'd go up 7 this direction. I'd go left 7. I'd go down 7. And then I would just connect a smooth circle around it. And that would be my circle. You like my smooth circle? Okay. If I got right on it, I could probably do it. But. It's like the wheels when they first invented wheels. That's what wheels were like. So. Yep, that's right. That's what I'm talking about. Fred Flintstone's car. Okay. All right, so back to this problem right here. Does this x squared plus y squared equal 25 look like the other problem? Yeah, what's the center of the circle? 0, comma, 0. Because this really, you guys, is x minus 0 squared plus y minus 0 squared equals 25. So do you see that x minus 0 is just x, right? So it's x squared. And y minus 0 is just y. So it's y squared. Do we all understand that? Okay? And so the center of the circle is at 0, comma 0. And what's the radius of this circle? 5. It's the square root of 25, which is 5. If I graphed this one, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5. Okay, here's the center of my circle. I would be up at positive 5, over at negative 5 here, down at negative 5 here, and to the right, positive 5. And my smooth circle, let's see if I can do a better job on this one. A little bit better. Okay, my circle is going to look like that. Okay, now, you guys, I'm not asking you to do this one by graphing, but I wanted to give you a picture of it. That's why I'm doing it this way right here. And then we'll go ahead and graph it. I'm going to show you why graphing doesn't work. Okay, let's go look at the second equation. 4y equals 3x. What kind of equation is this? It's a linear. So what would I do to graph it? Divide by 4. And I would get y equals 3/4 x. How do you graph linear equations? Why do I start at 0? Okay, there is a y-intercept. It's 0, right? I know what you mean, Cameron. Okay, so Cameron says we start at 0, and then what do we do from there, Cameron? Up 3. 1, 2, 3, and over. 1, 2, 3, 4. And down, and then we could also go down 3. 1, 2, 3, and over 4, right? Somewhere right in there. Now, this equation appears, if you were a guessing person, what would you say the answer to solving this system of equations would be by looking at the graph? (4.1, 3). Does that look like about right there? You go over close to 4 and up to 3? Somewhere around in there, right? It's kind of hard to tell by my graph. Maybe you guys drew a better graph. Then what about this one down here? Negative 3.9, comma what? Negative 2 point what? 9? Okay. Do you see what the problem is with doing it this way? Yeah, it's kind of hard to tell exactly where they intersect, right? It's probably close enough. You can probably get a pretty close estimation. But solving it using an algebraic method is a lot more precise. You're going to get the exact answer. So that's why we have to do it algebraically. And which method did I teach you algebraically? Substitution. The other day when I taught, I can't remember if it was this class or the other class, I taught you guys the substitution method, and then on the instructions on here I said, solve these, on the back I said, solve these systems algebraically. And everybody was like freaking out. Okay. Algebraically just means you're going to use an algebraic method, and the algebraic method we used is substitution, okay? So on the test when I wrote it, last night, I put substitution. Can I go back to this one? Right there? Okay, we're not done. We're going to go solve that one algebraically. Okay? I wanted to show you what it would look like graphing. Someone just wanted to see it. I wanted to show you what it looks like graphically before we did it algebraically. Okay? Tell me when you're done, Haley. Done? Okay, so we're going to go back this and solve this one algebraically. So to do that, we are going to have to use substitution. And so we got to solve for one of the variables. Which one's easiest to solve for? Solve for what? We've already solved for y in the linear equation, right? Because it's going to always be the linear equation that's easier to solve for, right? So I solved, and I got y equals 3/4 x. So we're going to substitute y equals 3/4 x in for the y up here. Okay, so we're going to take, I'm going to draw it in green down here so you guys can see. We have now x squared plus, and in the place of y, what are we going to put, everybody? 3/4 x squared equals 25. Now we got to simplify that down and make it into an a quadratic equation that we can solve. This is going to be x squared plus, what happens when you square 3/4? 9/16. Good job, Cameron. 9/16 x squared equals 25, right? Okay. X squared plus 9/16 x squared equals 25. Hey, you guys, on the test I didn't give you a fraction one, although it's not that much more difficult. All I need to do is times both sides of this fraction by what? 16. Okay, the denominator, good. So if I times both sides of this equation by 16, and I distribute that 16, I'm going to get 16x squared plus what? Yep, 9x squared. Who yelled that out? Good job, Kayla. All right. 25 times 16 is what? I believe it's 400, right? Okay, now, do you guys recognize what kind of equation this is? It is quadratic. What can I do to solve this? Well, I can what? That's exactly right, Carly. Good job. We're going to combine like terms. 16x squared plus 9x squared is 25x squared equals 400. What method would be easiest to solve this quadratic equation by? Which algebraic method? Taking the square root of both sides. But before I can do that, what do I have to do? Divide by 25. So we're going to divide by 25. And this is going to cancel out. I'm going to get x squared equals what? 16, right? And what's my last step? Square root both sides? X equals 4. Nope. That's one answer. 4. And -4. Good job. Plus or minus 4. Those are my two answers. Now, all that gave me is what, you guys? My two x numbers. Well, let's go look and see how it compares to what we did graphically. My two x numbers are 4 and -4. What did I get up here? 4.1. That's pretty close, right? Except for this time it's exactly 4. And this down here we had -3.9, but it's -4. Okay, so we are going to take now, and we are going to say, okay, one of our answers is 4 comma something, and the other answer is -4 comma something. And how are we going to find out what the exact value of the y is? Times it by 3/4. Yeah, we're going to plug it back into this equation right here for x. We're going to plug it in for x right here. What happens if, I'm going to go back down, what happens if I take y equals 3/4 times 4? If I plug 4 in for it, what's going to happen? Yeah, 4 is going to cancel out, and I'm going to get 3. And what happens if I go y equals 3/4 times -4? Yeah, those will cancel out, and that's -1. 3 times -1 is -3. And there are your solutions using an algebraic method called substitution. Got it? Let's review that. For those of you who are kind of struggling with this. Okay? All right. We'll do number 4, but let me just review this one first so you guys can get an idea. Okay, you guys look, right here. We had a circle equation, and we have a linear equation, right? So what I did is, all I did right here is I solved the linear equation for y. Got that? I got y equals 3/4 x. Okay, got that part? Okay. Then I took and I plugged it in. I substituted it into this equation up here, the y for the y right here. I plugged in and I did it right down here. I plugged in 3/4 x for y. You understand that? Thank you. 3/4 x squared equals 25. Okay? Got it? Then what we did is we squared 3/4 x and got 9/16 x squared, right? Because 3 squared is 9, 4 squared is 16. And then to get rid of the 16 on the bottom, I times both sides of the equation by 16. So I now have 16x squared plus 9x squared equals 400. And then I combined. I add 16x squared and 9x squared because they're like terms. To get 25x squared equals 400, I divided it by 25 to get, right over here, x squared equals 16. And then I took the square root of both sides to get x equals positive 4 and negative 4. Okay? That gave me my x values. All I had to do to find my y values was plug it back into the y equals 3/4 x. And I got those. Do you kind of get the idea, Carissa? Yeah. Okay. All right, Colby. Yes, you could. You could. Did you guys hear that? What Colby did? You could solve this for x first. So you could have divided both sides by 3 and got x equals 4/3 y and done the same thing. Just substitute in for x, 4/3. You got the same exact answers. Okay, let's have the next one. Number 4. Do you guys want to try it yourself first? Well, the only thing here, yeah, this one's quite easy too. Do you guys want to solve for, what variable do you want to solve for in this one? For x, okay, so if we add y to both sides, we get x equals y plus 6, okay? So we're going to make a substitution here for what? For x. So in place of x, this x right here, what are we going to put? Y plus 6. I'm not skipping steps. What do you mean? Oh, the only reason I showed you last time how to do it graphically is so you could see a picture of it. You don't have to do it graphically. You only have to do it algebraically. Say that again? Because these guys chose to do it that way. You can substitute for x instead of y if you want to. If I got y on this side minus 6, I would be substituting. I mean, the other substitution I could do is x minus 6, right? I could do. Yeah, both. You're going to get the same answer either way you do it. Okay? So whichever one you want. These guys over here just wanted to substitute for y. They wanted to solve the equation for y, x and substitute for y. But either one of those will work. Okay? So y plus 6 quantity squared. What are we going to do? Y plus 6 times y plus 6, right? What's that going to give me? Y squared plus 12y plus 36. So y plus 6 times y plus 6 equals this right here, you guys. You all got that? That's why I got it. You want me to write it out? Some of you guys are looking. Well, some of you guys are looking at me like, how did you get that? I know some of you guys get it, but let's just do this. If I go y plus 6 times y plus 6, that's what that 2 is telling me to do, right? So I'm going to go y times y is y squared. Y times 6 is 6y. 6 times y is 6y. And 6 times 6 is 36. Got it? And that's going to give me y squared plus 12y plus 36. Got that now? Okay, let's finish out the equation. Then what? Plus what? Y squared. Then what? Equals 26. Okay? Now, notice everything is in terms of y. And what's the highest degree term? Y squared. So this is what kind of an equation? Quadratic. What, Austin? Oh, okay. You just... Because Austin always shakes his head at me every time I say something. Okay. Y squared plus y squared is what? I can always count on two different looks from Austin. It's either the, what the heck did you do look? Or, no duh, I know this. I never get anything in between. Okay. All right. Okay. Right, Austin? It's awesome. I gave him the look, and he's like, why are you telling us that? I already know that part. And then the other part is, what'd you just do? And I'm like, well, you know, there's everybody in between. So, okay, y squared plus y squared is 2y squared. 12 plus 12y plus 36. And you know what? When we solve a quadratic, we always want to get everything on one side. So what else do I have to do? Minus the 26. I always want to set the one side equal to 0. What's 36 minus 26? 10. So we're going to get 2y squared plus 12y plus 10 equals 0. Oh, you know what? This equation, this works out nice. Huh? Where did I get the 2 from? See that y squared? And that y squared? When you combine those, add like terms, what do you get? Right, Austin? He already knew that. He could have told you that. Okay. All right. Okay. So, 2y squared plus 12y plus 10 equals 0. This one is a beautiful problem right here. We can solve this one. What's the best method to solve this one? Factoring. Well, Carissa. I mean, all right, okay. You guys look, if I factor out a 2, if I factor out a 2, that's what I get right there. And this becomes a very nice problem to factor because I can divide both sides by 2 right here. And those cancel out. And I get y squared plus 6y plus 5 equals 0. And that's an easy problem to solve by factoring, isn't it? What two numbers can I times together and get 5 and add together and get 6? 5 and 1.
So that's the answer, 5 and 1?
No. That's what the factors are. Y plus 1 and y plus 5. What are the answers for y? -1 and -5. All right. I heard someone over here saying they're so lost. Who said that? I'm ready to help you. Jalisa, what are you so lost on?
Never mind.
You got it? All right. Okay, now, you guys, are we done solving this problem? We've solved it for what? Y. Now we got to do what? Solve it for x. What are we going to do to solve it for x? Plug it in. -1 and -5. We got to go clear back up here because I got to see the equation. Okay. We've solved it for y, so I'm going to use this one right here. If you did it the other way, you're going to use the other equation and put it back in. You've got x, right? Okay, so x equals -1 plus 6. What's that one? 5. And x equals -5 plus 6. What's that one? 1. So, I got 5 and 1. I got 5 when I put in -1. So my two answers are 5, -1 and 1 comma, -5. That's where those two intersect. Cool, huh? I mean, does math just not wake you guys up in the morning, make you excited to be here to school? Haley? Huh? Why didn't I use the quadratic? Hey, you guys can use the quadratic. I will show you. You'll get the same answer. Right here. Okay, let's go back down here. Did you use it with this one right here? Is that where you use the quadratic? Okay, -b. What would that be? -12. Plus or minus the square root of, I'm going to put b squared minus 4ac up here. 12 squared is 144. Minus 4 times 2 is 8. Times 10 is 80. What's 144 minus 80? 64. All over 2a. 2 times 2 is 4, right? -12 plus or minus square root of 64 is 8, all over 4. -12 plus 8 is a -4. Divided by 4 is a -1. There's our -1. -12 minus 8 is a -20. Divided by 4 is a -5. These guys wanted to know how to do it using the quadratic formula. It's not easier than you guys. -12 minus 8 is a -20. -12 plus 8 is a -4. Hey, you guys, let me answer that question. That's a very good question. Are you ready? Everybody listen. Everybody, some of you are saying, why didn't we just do it this way from the beginning? Okay? You know what? You do it whichever way is easiest for you to do. I think once you guys learn how to factor, you'll find out that if they factor, it's a lot faster to do them that way. Okay? That's why I taught you the factoring method. What? But if you think it's faster to do by the quadratic formula, use the quadratic formula. Some problems you can only do by the quadratic formula. You can't do them by factoring. But most of the problems you guys are going to counter in your math classes are going to be able to be done by factoring. And if you learn how to factor now, when you experience quadratic equations later, your homework will be so much faster. Your tests will be so much faster. Your ACT tests, where time matters, will be so much faster. Okay? So that's why I teach you the factoring method. I remember when I first learned this, I used the quadratic formula for everything, until I learned that factoring was a lot faster, and I started using that. So, okay? Factoring, especially the ones where the coefficient is x squared, the coefficient of x squared is 1, it's really fast to do it by factoring. You can usually look at it and say, okay, are there two numbers I can times together and get this one, add together and get that one? There they are. Okay? Any questions? All right. Okay, the question was asked, do we need to know the equation of a circle formula test? You just need to be able to recognize circles. Did you guys notice that both the questions 3 and 4 on here, they're x squared plus y squared? We didn't go x minus something squared plus y minus something squared on either one of them. We made them pretty simple. On the test, it's just like that. The center is going to be a 0, 0. On the test, yeah. I didn't want to take time because you guys were supposed to learn about circles already. You haven't. I introduced them to you. Hey, did you guys notice that 4 and 6 are the exact same problems? You don't need to do it twice. Well, one way you're supposed to do it algebraically, and the other way you're supposed to do it graphing, but I said you could just do them algebraically, because graphing, I showed you the problem with graphing is they're not very precise. Okay? Oh yeah, 5 and 1. Well, in 5 and 1, I told you number 1 I want you to do by graphing. So 5 you can do by algebraic method. What? Well, you got to be here, Kobe. Hey, the graphing is real easy. You do it in your calculator. Okay? I believe I did number one with you guys last time with the calculator, but we'll do it again. Or actually, I think I gave you guys a different problem. Hurry back. Hey, look, problem number one. If you're going to do this one graphing, all I'm going to do is I'm going to go to my y equals, and I'm typing x squared minus x minus 6. And for my y2, I'm going to put in 2x minus 2. Okay, you got it? Now, you have to hit zoom 6 for a standard window, so you get the same window as I do. Hey, you guys, how many times have I gone over the window a lot with you? Yeah. You guys, look, if you hit the window button, you have your X min and your X max. A lot of you guys are asking me questions, say, well, why doesn't mine look like yours? It's because you probably have a different window. I usually hit, when I first start graphing something, I usually hit zoom 6. So I have a standard window, and then I can change my window from there so I can see the parts of the graph I need to. Look at this problem. Can I see the parts of the graph I need to? Okay, I can. Now, we learned a little nifty secret last time on this one. What can I use to help me find where they intersect? Not trace. Under the calc menu, if you look at the trace button, above it says calc. Access that menu. Hit second and trace. And number 5 says intersect. And if I go there, all I have to do is take my cursor to about where they intersect. And it's on my first curve, which the first curve I put in was my parabola, right? My quadratic equation. And I hit enter. Now it's asking me for a second curve guess. Well, guess what? It's already there, isn't it? Enter. I don't know. That's how they designed the calculator. Third one is the overall guess. Well, we're about right where they intersect. All you have to do for a guess, all you have to do is get close to where they intersect. Just close. You don't even have to be right on. Just close. Because it wants to know which one you're trying to find. And my answer is 4, 6. So right here, for problem number 1, I found where they intersected. One of them is 4, 6. So I hit second trace again, go to my calc menu. I look at number 5, that's where my intersect is. I hit number 5, and I take, using my left arrow key. Remember, you can't use your up and down keys. You got to use your left and right keys. Mine's slower than yours because it's on the computer rather than the calculator. But I just take it close to where it intersects, just hit enter 3 times. -1, -4. That's where they intersect. Okay. Addie, what? Nope. You won't need to know how to do that. You guys, this whole test is on quadratics. Does everybody understand that? Do you know how to find the discriminant? If you know how to find a discriminant, the first 3 problems are finding a discriminant. Okay? Do you know how to solve a quadratic equation? Yes. Do you know how to solve it when it just requires taking the square root? Do you know how to solve it by using the quadratic formula? Then that's all you need to know. There's some of them that will be easier done by factoring, but you can use the quadratic formula if you want. And do you know how to solve systems by substitution? Then you should ace this test if you know how to do all that. Okay? Now, I'm going to do a short review. Actually, we're going to turn in this assignment really quickly. Oh, we have not turned in that assignment yet? We need to do that. Okay, the first problem we're going to review is this one right here. And this was one that was on your assignment. Okay, just so you know. And what it's asking you to do is to solve this quadratic equation in whatever method you want to. Okay? To solve this in whatever method you think you know how to do best. Okay? You can see if it will solve by factoring. You can use the quadratic formula. Probably completing the square is out of the question because we didn't spend enough time on that one. But you don't need that because you can solve every problem by the quadratic formula. This one, probably taking the square root of both sides won't work on this one because it has a linear term, right? So you could solve it by graphing, put it in your calculator and see where it crosses the what? Where it crosses the x-axis. You could do that. Okay, whatever method you use on the test, you'll need to show your work. Okay? I'm going to pause it for a second while you work on it. All right, how many of you guys have solved this one by factoring? Raise your hand if you did it by factoring. Hi, I want to see how many are trying to do it by factoring. 1, 2, 3, 4, 5, 6, 7 of you, 8 of you. How many of you have done it using the quadratic formula? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 of you. How many of you did it by graphing? Okay, graphing's not always that accurate, so it sometimes is. Depends. Okay, you guys, this one can be done by factoring. There's two ways you can do it by factoring. One way is you'll notice that 2 will go into all three of those numbers. And so you can factor out a 2. Okay? And then divide both sides by 2 just to leave x squared plus 9x plus 14 equals 0. Because when you divide 0 by 2, you're going to get 0, right? So that problem kind of reduces down. It makes it easier to do. Yeah, just the x. This is a quadratic equation. We're just solving a quadratic equation. We're not solving a system. We don't have 2 equations. A system, you guys, is when you have 2 equations and you're trying to find the points where they intersect. So you got to find both x and y and the points where they intersect. Okay, so then I'm looking for the 2 numbers I can times together and get 14 add together and get 9. What are those 2 numbers? Yep. 7 times 2. Good. So I get x equals -7 and x equals -2 as my answers, right? That's one way you can do it, by factoring. Another way you can do it by factoring is to list the factors of 2, which are 1 and 2, and the factors of 28, which are 1 and 28, 2 and 14, 4 and 7, right? And you can list those. And then you've got to find the ones that add up to be 18 in the middle. I can see that 2 times 7 is 14. So 2 times 7 is 14. 1 times 4 is 4. They add up to 18, right? So I would factor it like this. I'm going to have a 2x and a 1x. And I times the 7 by 2. So it has to be in the opposite thing as 2. And so I would write those 2 equations. I would set 2x plus 4 equal to 0. I would minus 4. I would divide by 2. And there would be one answer. On this one, I would get x equals -7. So there I have -2 and -7. So there's another way you can do it. Although I think it's easier if you can factor a number out to do that first, like 2. Okay? Or you could have used the quadratic formula. If you use the quadratic formula, you would have went x equals -b, which would have been a -18, plus or minus the square root of, let's find out b squared minus 4ac real quick. 18 squared minus 4 times 2 times 28, and those are large numbers, so someone type that in. Tell me what you get for the discriminant. What? 100 exactly? Okay, that's nice. Square root of 100 all over 2 times 2 is 4. And then I would have got negative 18 plus or minus 10, because the square root of 100 is 10, all over 4. And then I would have went negative 18 plus 10. What's negative 18 plus 10? Negative 8 divided by 4 is negative 2. And I would have went negative 18 minus 10, which is negative 28 divided by 4 is negative 7. So you could have used any of those three methods, whichever one you prefer. Quadratic. We did it two different ways factoring. And then we did it one way on the quadratic. Okay, how many of you use both? Good job to check it. Good job. Hey, you guys, if your numbers come out to be whole numbers like these, that means it could have been done by factoring. Got it? If you come out with square roots of irrational numbers, okay, if you come out with irrational numbers, that means it couldn't be done by factoring. Okay? What? Could you factor the decimals? I'm not sure what you mean. Well, I think, no, because they're irrational numbers, it would be very difficult. Yeah, you could come up with square roots of numbers. Yeah, you could probably do that. But it would be very difficult. Okay, now, I want to just test you guys, just see if you guys remember what a discriminant is. I'm going to give you 3 problems. Okay? I want you to tell me, I want you to find the discriminant and tell me whether it has 2 real solutions, 2 imaginary solutions, or 1 real. Okay? So let's say I have something like this, x squared plus 15x plus 12 equals 0. Okay? This one right here is going to be x squared minus 3x minus 4 equals 0. And this one right here is going to be x squared plus 6x plus 9 equals 0. I want you to tell me if it has 2 real roots by looking at the discriminant, 2 imaginary roots, or 1 real root. Okay, I added a 4th one, so do that one as well. Okay, you guys on this first one, b squared would be 15 squared minus 4 times 1 times 12, right? b squared minus 4ac. I'll put that up here. We're finding b squared minus 4ac on each one, the discriminant. Well, that's going to be 225 minus 48, isn't it? What is it? 177. Now that's a positive number, so we're going to get 2 real roots. Got it? Okay, next one. b squared would be 9, because negative 3 times negative 3 is 9, minus 4 times 1 times a negative 4. Well, that's going to end up being 9 plus 16, which is 25, right? So that's 2 real, because it's positive. Okay? The next one, you're going to go b squared is 36 minus 4 times 1 times 9, which is going to make 36 minus 36, which is 0. So there's 1 real solution, because that's a parabola where it sits on top, right on the x-axis, right? The vertex. And number 4. Okay, b squared is going to be 4 minus 4 times 1 times 10. Well, 4 times 1 times 10 is 40, so we're going to get 4 minus 40, which is a negative 36. So we're going to get 2 imaginary since it's negative, right? Got it? Now, if I drew a picture of each one of these, I don't know what the graph exactly looks like, but this one's going to cross the x-axis twice because that's 2 real. Same with that one. However, number 3 right here is going to have its vertex sitting right on the x-axis, so it has one real solution. And on the imaginary one, it never crosses the x-axis, does it? And so it has two imaginary solutions. Do we get that? Okay, good. All right, thank you. Okay, now, is that it with that? Okay, now, let's do this one right here. Solve that one, you guys. Solve that one. Whatever way you think is best. Keep in mind, you can always solve every single one of them by the quadratic formula. However, there's a much faster way to solve this one. Oh, we're going to take tests next time. Okay, here we go.
Oh, I'm not going to be here next time either.
Divide by 3. Take the square root of both sides. How many of you did it that way? Okay. That's called solving for x by taking the square root of both sides, right? Because whenever there's no linear term, notice that this had a quadratic term and a constant term, no linear term. Whenever that's the case, this is the fastest method to solve those by. Do you understand that? Now, it doesn't mean it's always going to come out to be a real number. I could come up with the square root of something, right? Because in this case, 9 is a perfect square, so it came out to be plus or minus 3. But that's the fastest method. How many of you use the quadratic formula on this? Okay, how many of you did it by graphing? This is by far the fastest method, okay? Good job. All right, now, okay. You guys, do you feel like you need to go over, well, let's go over one more. I can think of one more I want to go over. Okay, let's go. Hey, how many of you aren't going to be here next time you mentioned? Where are you guys going to be? Okay. I need you to take the test today or tomorrow. So I'll give you a few minutes here in just a second. Let's do one problem. Okay, here we go. Okay, solve this one. Best way you think possible. Okay, here we go. I'm going to first of all find the discriminant to see what kind of answers I have. So b squared would be 4 minus 4 times 5 times 7. Okay, now I have 4 minus 20 times 7 is 140, is that right? And 4 minus 140 is a negative 136. Is that correct? Okay, so I have x equals negative b would be negative 2. That's right. That should have been negative 1. Plus or minus the square root of negative 136 all over 10. 2 times 5 is 10. Now, I have a negative discriminant, which means I'm going to have two imaginary solutions, right? Okay, I'm going to have an I. I know that 136 can break down into 2 times 68. Is that right? And that can break down to 2 times 34. And I know that breaks down to 2 times 17. I have a pair of 2s. I don't have a pair for that 2. I don't have a pair for that 17. So those are loners. So it's going to be 2 square root of, 34. 2 times 17 is 34, right? Well, that's just for 136. Now we'll add the I here, right here. Negative 2 plus or minus 2i square root of 34, because it was a negative, divided by 10. And what number will go into all three of those numbers? 2. So that's going to be negative 1 plus or minus I square root of 34 all over 5. And that's what x is equal to. There's two numbers right there, right? A plus 1 and a minus 1. That's why we have the plus and minus. And that's your answer. Okay? And you should know how to do one of those. That's it. Okay, so you guys' test. Let me just go over this. You got to know how I did those three problems. You need to know how to find the discriminant, tell whether there's two imaginary, two real, or one real. Got it? then you should be able to, I'm going to give you about 5 or 6 problems where you have to solve quadratic equations. And you've got to do it, you can do it whichever way you want. Just do it a correct method and show your work. Huh? You can use quadratic formula, you can use factoring, you can use graphing. Okay? This is crazy numbers. Well, the only way to do this one is the quadratic formula, because it has crazy numbers. I don't know what you mean by crazy numbers, because, I mean, to me, that's crazy numbers. Well, if I took the square root of 34, I would have irrational numbers, right? And I would have crazy numbers. But I want you to leave the answers like this. Oh, well, if you try to do this one by graphing, is that what you're talking about? Well, let me just talk about this, you guys. Would it be a good method to do it by graphing if you can't tell exactly where it crosses the x-axis? No. In fact, I would probably tell you, don't do any of them by graphing if you want to do well on the test, okay? Do them by either factoring, taking the square root of both sides, or the quadratic formula. One of those 3 ways. Okay? Got it? Now, and then you also need to know how to solve the systems using the substitution method. Okay? The very beginning of class. Okay? Hey, you guys, all you have to remember about substitution is solve for y or x, and it's usually the linear equation, right? Okay, listen, you guys. All you have to do to solve a system is solve for y in the linear equation, substitute that in for y in either the quadratic equation or the linear or the circle, and your equation will become a quadratic equation that you can solve by using the quadratic formula. That's all you have to do. Got it? That's all you have to do on that one. It's back to the quadratic formula again. Okay? Or factoring if it factors. Okay? All right.